subscribe now and press the bell icon. Never miss an update.
Hi guys, this is Algebraic. Welcome to my mathematics class. Let's see today's topic. We have today's topic, the derivatives part 2. I've taken back important questions from the derivatives. We will do by first principles, or you can say from definition, or you can say by using delta method. Okay, one video I made on delta method, or you can say by using the definition, or from first principles. If you want to see that video, most welcome, and go through that video. You will get definitely the more ideas on the delta method. Okay. So very important questions I've taken, and a little bit difficult questions also. So let's move firstly the definition. Let's recap the definition. What is the definition of the derivatives? The definition, from definition of first principle, or let's see this one, this part, this statement is called the definition of the derivative. In shortcut I've written, if y is equal to f of x, this is a function, y is equal to f of x, then dy by dx means derivative of y with respect to x is equal to limit of delta y by delta x as delta x tends to 0 is equal to limit of f of x plus delta x minus f of x over delta x as a delta x tends to 0, provided that limit exists. If this limit does not exist, then derivative also does not exist. To see the derivative of y with respect to x, this limit should be existed, right? Let's see, we will use this definition whenever you get the questions by using the definition of first principles or by delta method. One more name is there for this, ab initio. You can use this one formula, okay, or this one definition you can say. So let's start. Delta means, okay, here delta x means small increment in x, and delta y is also the corresponding small increment in y. Let's start the solution of first question by using first principles. Solution. First of all, we'll write down the let y is equal to ax plus b over b. Okay, is equal to, we can write down here x over b plus 1 first, and let delta x be the small increment in x, and delta y be the corresponding small increment in y. Then the next statement will be your y plus delta y is equal to a over b times x plus delta x. X is a variable, and plus 1, the second one. Or you may write down delta y is equal to a over b x plus delta x plus 1 minus a. Sorry, here we can write down here minus y. We have shifted y from the left hand side to right hand side. A over b times x plus delta x plus 1 minus y. What's the value of y? Instead of y, we can plug this one, a by bx plus 1. There is a negative sign, because of this plus 1 becomes minus 1. And let's simplify. A upon b times x plus a upon b delta x, or 1 positive 1 and negative 1 cancel. We will have here minus a upon b x. So cancel. We got a by b delta x. Okay, or we can get this is delta y, or in the next step delta y by delta x, or using alternator we can write on delta y by delta x is equal to a upon b. So we got the value of a delta y by delta x is equal to a upon b. Now we can use this definition. Now or you can write on we have, or we know, I'm writing here, or we know dy by dx is equal to limit, I'm using definition, as delta x tends to 0 delta y over delta x, or limit delta x tends to 0 delta y, already we have got the value of delta y by delta x is a over b is equal to, as you know, the a upon b is a constant. Limit of a upon b as delta x tends to 0 is also equal to constant, the same thing, same constant, a upon b. So therefore we can say the derivative of ax plus b whole over b is equal to a over b. This is the this is the derivative of this function by using the first principles, or from first principles, or by from definition, or by using the delta method, you can say. So easy. And how you have to get the value of delta y by delta x. Okay, so one more video I have already made on this topic. I have done the work with explaining each and every step. You can go through there, right, on that video also. Okay, so I'm taking the next one question. I think you are clear about this question. Yeah, now no problem. Okay. Let's say the second question by using definition. Let y is equal to x plus delta x. We can write down x plus x root x. Sorry, delta x, not okay, root x, and is root x, or root x we can write on x raised to power 1 by 2. I've converted in terms of power, x raised to power 1 by 2, or x to the power 1 by 2. Let's say this one first, and thereafter you write the same line, let delta x be the small increment in x, and delta y be the corresponding small increment in y. Then we will have y is replaced by y plus delta y. Y is a variable, and x is x plus delta x, and plus x raised to power 1 by 2 and x plus delta x whole raised to power 1 by 2, or delta y is equal to x plus delta x and plus x plus delta x whole raised to power 1 by 2 minus y. Now let's put the value of y from first. Here you can write an x plus delta x, same line, and within bracket x plus delta x whole raised to power 1 by 2 minus y. So using this one, minus y minus x raised to power 1 by 2. Okay, using first, here x minus x, they will cancel out, and we have delta x plus delta x raised to power 1 by 2 minus x raised to power 1 by 2. Okay, done, no problem. So after that you will divide both sides by delta x. delta y by delta x, because why we are okay, because we need this delta y by delta x, that's why we are dividing both sides by delta x. Delta x plus delta x raised to the 1 by 2 minus x by 2 whole upon delta x, or is equal to, now we'll write down separately, on delta x over delta x plus delta x raised to power 1 by 2 minus x raised to power 1 by 2 whole over delta x, because we can get this in formula, that's why I have kept in one as a one term whole. Okay, here you are going to get here 1 and the plus, same thing you will write down, there will no change, delta x. Yeah, this is the value of delta y by delta x. Okay, now I'm writing here. Now we have in definition dy by dx is equal to limit of delta y by delta x as delta x tends to 0. Limit of delta y by delta x 1 plus, or big bracket or square bracket you can say, or x plus delta x raised to the 1 by 2 minus x raised to the 1 by 2 over, here I forgot to write down delta x, delta x as delta x tends to 0. Okay, as you know 1 is the constant, so limit of 1 is 1, so plus limit of x plus delta x raised to the 1 by 2 minus x 1 by 2 over delta x as delta x tends to 0 and 1. So little bit modification we will do here. You can see whatever limit, here I'm writing x plus delta x as delta, okay, or tends to x, and here x plus delta x whole raised to the 1 by 2 minus x 1 by 2 and x plus delta x minus x. After doing some arrangements, you can check whether the new arrangement is equal to the previous one. So 1 1, okay, there is no problem, and a plus sign, delta x tends to 0, limit delta x tends to 0, x plus delta x tends to 0 is equivalent to delta x tends to 0, same. And numerator same. In denominator we need delta x, in the previous term we have delta x, and in the new key line, let's see, x plus delta x minus x, when I open this bracket and x will be cancelled out, and you will have ultimately delta x in denominator. So this means, okay, this line is exactly equal to the last line, so there is no problem. Now why we have converted this expression in this form, so let me remind you one formula we have, limit as x tends to a, x raised to power n minus a raised to power n over x minus a is equal to n times a raised to power n minus 1. So we can use this one here, right? So especially to use this formula or a limit theorem, you can say I have converted this expression in this form, okay, and say this you same, and this, okay, and this one, this should be same, okay, this and this one, right? And here x minus xa, right? So exactly this one is in this form. Now we can write down, we can use formula 1 plus, so 1 by 2 x second term, here second term is taken, so second term is this one, x n x 1 by 2 minus 1, 1 plus 1 by 2 x raised to power here minus 1 by 2. You may write down 1 plus 1 upon 2 root x. I think you understood it. So this is the derivative of this function, alright, by using first principles. So I think you have no problem. So here you may write down reason. So reason, okay, in reason, okay, same this thing you will copy, copy and paste here. No, this will be done. So this way you have to do. I don't so think you have any problem. Okay, now I'm going to tell you the last one question, right? Last but not least, and this one is a little bit harder than first one, second one, right? As compared to the first and second question. So let's start. The last one here, and now I'm going to. Y is equal to ax plus b over root x. So I'll simplify firstly before starting writing, okay, delta x, delta y, before taking, okay, x over root x and plus b upon root x. And here a x, and this will be a root x, x over root x is equal to root x. By using the law of indices, this x raised to 1 minus 1 by 2, you will get x raised to 1 by 2, which is equal to the root x, okay, and plus b raised to power x raised to minus 1 by 2. A times x raised to 1 by 2 plus b times x raised to power minus 1 by 2. Let's say this one is a first, and here you need to write down let delta x, as we have written in this last question and last solution of the second question, or in first question you will write down the same thing. Then you might have definitely this one, y plus delta y, a x plus delta x raised to power 1 by 2 plus b x plus delta x minus 1 by 2, or delta y is equal to a x plus delta x raised to 1 by 2 plus b times x plus delta x whole raised to minus 1 by 2 minus y. So let's plug the values of value of y from first. You will get here a x plus delta x raised to 1 by 2 plus b x plus delta x raised to minus 1 by 2 minus y, a negative sign, so sign will be changed, okay, minus a x raised to 1 by 2 minus b x raised to minus 1 by 2. So using first you can write down here, otherwise no need also for convenience. Now a common we can take, simplification, a common, inside the square bracket we will have x plus delta x 1 by 2 minus x raised to power 1 by 2 plus, and b common, inside the square bracket we will have x plus delta x raised to power minus 1 by 2 minus x raised to power minus 1 by 2. So easy, not so difficult. Now delta y over delta x, now we will divide both sides by delta y. Yes, same thing you will copy, and delta x, okay, the same thing you will copy here and over delta x. Lego space I've done this way. Then thereafter you will write on the separately a and x plus delta x 1 by 2 minus x 1 by 2 over delta x, and plus b x plus delta x minus 1 by 2 minus x minus 1 by 2 over delta x. This is the value of delta y by delta x. Now let's apply the definition. We know dy by dx is equal to limit delta x tends to 0 delta y by delta x. Okay, and limit as delta x tends to 0, instead of delta y by delta x, whole things we will write down this one, whole things. Okay, okay, let me write down. Okay, no problem. Here a x plus delta x 1 by 2 minus x 1 by 2 over delta x plus b x plus delta x minus 1 by 2. So lack of space, actually should not write this way, minus 1 by 2 over delta x. Okay, now we can write on a as limit delta x tends to 0 x plus delta x 1 by 2 minus x raised to 1 by 2 over delta x plus b limit delta x tends to 0 x plus delta x raised to minus 1 minus 1 by 2 over delta x. Now I think you understood. Okay, the same formula we will use here, but we have to write down firstly in that form, limit x plus delta x tends to x, and here x plus delta x raised to 1 by 2 minus x 1 by 2 and x plus delta x minus x plus b times lack of space I am writing here x plus delta x tends to x and x plus delta x 1 by 2 minus x minus 1 by 2 over x plus delta x minus x. X is cancelled, delta x. Okay, x6, okay, we can remove, so delta x tends to 0. There is no problem. Same, this whole line is also equal to this line, right? Now I'm using formula. Using this formula, here writing is equal to a times 1 by 2 x raised to power 1 by 2 minus 1 minus 1 by 2 for this. Sorry, here b also, I think b times minus 1 by 2 x raised to power minus 1 by 2 minus 1. You may write down since limit as x tends to a x raised to of x raised to power n minus a raised to power x minus a, limit of this function as x tends to a is equal to n a raised to power n minus 1. Using this, how we have got this line of using this formula, we have written this. Now I think you will not have any problem. A by 2 x raised to power minus 1 by 2, here actually plus by mistake, okay, I written plus, now it will be negative b upon 2 x raised to minus 3 by 2. Let's make power positive. A upon 2 x raised to 1 by 2 minus b over 2 times x raised to power 3 by 2. By law of inverse is this power becomes positive. Now we'll take LCM. LCM is 2 times x raised to power 3 by 2 and x times this means x raised to power 3 by 2, 2 to same. So here we need only x, okay, ax minus b. So this is the derivative of this function with respect to x. I think now you understood how to find out the derivatives of algebraic functions from definition or from first principles, or by using the delta method, you can say. If any problem, you can tell me. Don't hesitate to ask question. More you ask, more you will get. Thank you very much for watching my video. Please don't forget to share, like and comment. Okay, bye bye.